Hello, sir. Can I share now?
Yeah, you can hear.
Sir, for the exam, will you be provided calculators?
Huh?
For our exams, we would be allowed to take our calculators with us?
Uh, so that I am not sure. You just check with NPTEL team. I think they will provide some virtual calculator.
Oh,
Mm, Virtual calculator and some tables they will provide.
sir, and for the z value and the p value test, we would be given the tables, or without the table, how we can calculate? This is the main question.
They will give some tables in exam. Okay.
Thank you.
Basically, we don't have that much knowledge. Okay, how that exam should be. We are the TAs, so we will be coming for live interaction sessions. Okay. If you
Okay,
are
sir.
having specific questions, exam related questions, you just mail to that NPTEL team and they will give clear idea. Actually, we also don't know the
Thank you.
exam procedure. Yeah. Yeah. Good evening, all. I think this is live session of week 10. So I hope all of you gone through the lecture videos of Professor Ramesh sir. So in that week, he explained chi-square test and cluster analysis. So I'm going to give, okay, most of the time he explained theoretically. Okay, I will give, okay, like hands-on. I will give some examples using Python for chi-square tests and cluster analysis. We will discuss one or two cluster analysis. Okay. First we will start with chi-square test. Okay. So I hope my Google Colab notebook is. Can you able to see my Google Colab notebook, right? Mm, yeah. Okay. So basically, whatever you have learned now, okay. Previously, okay, if you gone through previous lecture videos, we have done t-test, right? Now you are going to come up with some new concept that is chi-square test, okay. So what is this in terms of this statistical hypothesis testing, okay? So the t-test majorly you are going to use for numerical variables, like if you are having any numerical data or any variables which is having any numeric values. Okay, so you are going to apply t-test. Okay, you can frame some hypothesis, statistical hypothesis. Based on that, you are going to do that t-test. Okay, you need to identify that p-value. Based on that, whether you are going to accept your hypothesis or you are going to reject it. Okay, so now come to chi-square test. Okay, when you are going to use chi-square test means, so whenever you are having a categorical attributes. Okay, so the attributes will contain like some categorical values. Okay, in such cases you are not allowed, or you are not allowed to do a t-test. Okay, so in such cases you can go for chi-square test. Okay, so um, like in t-test we have seen, okay, like some population tests, some examples, okay, in my previous lecture videos also. Okay, so it will be there. Okay, like population mean and all for numerical values. Okay, come to chi-square test. Okay, first we will see one example for chi-square goodness of fit test. Okay, then we can go for chi-square independence test. Okay, mm, for that, okay, so we need to take some example. What I am doing is I am trying to create some fake demographic data, like, okay, I am going to take nation. Okay, Indian nation. Inside that Indian nation, okay, we will take some language. Language is one of the variable. So we will take, okay, the number of rows and columns. Okay, the number of rows will be the language speaking in the nation like India, and we will take another thing is nation. Okay, so we will see before we will create that demographic data. As of now I am creating the demographic data. This is not exact values. Okay, I'm just giving some demographic data to show how this chi-square test will be performed. Okay, so for that, if you want to do chi-square test, we need some data. I am creating that data. Before that, we want to import some packages for this chi-square test. Okay, so that will be numpy, import numpy as np, and import pandas as pd, then import scipy, then import scipy stats package, stats as stats. Okay, to try to import this package, numpy, pandas, and scipy. Okay, so after that, what we are doing is we need to check, okay, chi-squared goodness of fit test. Okay, to check whether this demographic numbers. Okay, so pandas has pd, scipy, no model, pandas, there is some typo. So you need to import this one. Okay, in which scenario you want to use, okay, this chi-square testing. For example, I will give few examples. Okay, like demographics of members at your church or temple or school. Okay, you need to match the data with some population with nation. Okay, or else we'll take one more example. For example, you want to browse. Okay, you want to use some browser preferences. Now you are using, okay, I am using Google Chrome, you are using Mozilla, some people you are going to use Internet Explorer. Okay, so what you want to do is you need to found, okay, you need to analyze your data. So who are using this Chrome browser, who all are using Mozilla, or who are using Internet Explorer. Okay, so if you want to do such kind of analysis, okay, so you can prefer chi-square test. Okay, this thing, okay, this chi-square test especially meant for whenever you are having categorical data. Okay, so um, for that you want to import this package numpy, pandas, and scipy. So after that, what I am doing is I am trying to create some fake demographic data. So I am giving I am creating one data frame with the variable name as national. So if you want to create data frame, you need to use pandas, right? PD dot. So you can create PD dot data frame. So inside this, I am giving as, okay, uh, some number. So I am going to take it as, so inside this I am creating some data. For example, I am taking the English language, whoever is speaking English language, I am going to take that, okay, inside this nation. You just assume that India is one nation, that is the variable name will be national. So the English, so count, I am giving some count. Okay, there are this number of people. Okay, like uh, 1 lakh people, they are speaking English as one language, and I am giving some more data for Hindi. Okay, so some people will speak Hindi. I am giving some more number. Just so this is not exact data. I'm just creating some fake data. Okay, so then you can give the other languages. Okay, like Tamil. Some people will speak Tamil. You can give that. You can create that frame 50,000. Then you can give another language. Okay, I am just creating. Telugu, wording. We are giving some more count. Okay, so this number, okay, this is language. After that we are giving some count in this data frame. So if you are having any other languages, you just give others as other. You just give some number. There may be some 35,000 people will speak the other language. Okay, so let me execute this cell. Okay, so this is how I'm creating a data frame with different languages. Like you assume that in India there will be population inside that population. This many number of people. Okay, like 1 lakh people will speak English, another 60,000 will speak Hindi, another 50,000 they will speak Tamil, then 15,000 Telugu, other language will be like this. Okay, like this I have created one data frame. Okay, so then what do you want to do is, so inside this nation, this is national data. What you want to do is, inside this you just come with some narrow down. Okay, you take a particular state. Okay, for example, I am taking TN. Okay, TN means Tamil Nadu as one of the state. So inside Tamil Nadu, okay, inside nation, this is my data. Inside Tamil Nadu, inside state, I want to create some other data. Okay, so inside this state, similarly, okay, like this, I'm giving some more. I'm creating some more data. PD.data frame. Okay, inside this, okay, this is specifically this is meant for Indian. This is meant for state. Okay, you just change. Okay, maybe it is less than that. You give some number like 6,000. 600 people will speak English. Then remaining 300 people they will speak Hindi and Tamil. Okay, 250 people they will speak Tamil. Then Telugu, some 75. Okay, so like others they will speak. Okay, or like 150 they will speak other language. Okay, so this is another data frame I have created. So now what you want to do is, you want to create a table for this. Okay, all these are like this is okay. This English will be the like categorical data. You are going to have this data. What we are doing is, we are trying to create a table for this national wise. Okay, nation wise, at the same time state wise. Okay, so for that what I am doing is, I am creating national table. National table. Okay, then you use your PD, then cross tab, just creating. So if you want to create, so you need to give. Okay, your index will be based on national data. It will starts with 0. So I'm creating one more column, that is count. Okay, so you have the data. This count will be comes under here. Okay, COUNT. Let me execute this one. COLUMN column. Okay, we just create this columns. So similarly, you create another table for the state wise data. Same thing. So instead of national, you just create TN, that is Tamil Nadu state. Instead of national table, you just create TN table. Okay. So then what you want to do is you just print this data, how it look like. Okay. Print national and print national table. So this is my one data frame. For this data frame, you have created, okay, a table. So inside this, you have index, okay, index by language, and you are going to maintain this is one count, okay. So similarly, you just repeat these steps for your state-wise data also. So what we are doing is we are trying to print, we are trying to create some fake demographic data, okay. Because we need to do size for test, we require some data, right? That data we are creating by ourselves, okay. So now I have created my data print TN, okay. I have national wise data and I have state wise data. So what you want to do is you want to do size square test, okay, based on this, okay, mm, based on this data, okay. So I think you already know that size square test formula, that is sum of observed minus expected whole square by expected, okay. Those who don't know chi-square formula, you just to go through or you refer the previous lecture videos of Professor Ramesh, they will explain, okay. If you want to do chi-square, you want to calculate the chi-square statistic, you want to use that formula, okay. Sum of observed minus expected whole square by expected, okay. So that is the formula. So from that, what you want to do is you need to identify the actual observed, okay, observed data, at the same time expected data. So what kind of data you have observed from here, at the same time what kind of data you are expecting, okay. So you are going to get such kind of values. So actually observed data in the sense means your actual observed count for each category. So I told you that chi-square test will be applied on categorical data. This is my categorical, okay. English will be the one of the language, okay. So this is, you just assume that language is one of the variables. You may have different names and their ID number, then language is one of the variable, okay. So in that cases, the categorical data will be like this: English, English, Hindi, 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 Telugu, Telugu. Like this, you are going to get your variable values will be like this. So then, if you are having categorical data, you are unable to apply t-text. So for that, what you want to do is you can create a data like this. Okay, that is categorical data. One column you are going to maintain that categorical values, okay, variables like English, Hindi, Tamil, Telugu. Then you maintain that count here, okay, for each and every language. It will appear how many times in your data set, okay. So as of now, I created all these data frames uh, as I want to demonstrate this size per test. But in real time, you will get this categorical data inside your data set itself, okay. So that may be categorical value like language, or else if you are having gender, gender is one of your variable that is present in your data set, okay. Inside that gender, what you are going to have, you are going to have male, female, male, female, 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 male, like that you are going to have data, right? So in such cases, you want to apply that size per test on that particular category, how you can do? So you can do like this, okay. You need to maintain some count for that categorical value, then you need to observe the data, then you can expect some value, okay. You apply this chi-square test based on this formula. Again, I am repeating, chi-square test will be sum of observed minus expected whole square by expected. Okay, this is standard formula. Those who don't know, you just refer those lecture videos, or you go through that mathematics. Based on that, you can able to do it. Now, what I am doing is I am trying to apply that formula for this data, whatever the data I have created. So for this data, I am trying to apply the chi-square test. Okay. So for that, what we are doing is, So initially we need to find observed data. I'm giving same name. Observed means the same name. Observed. So initially we will see it for TN table. TN table means state-wise table. Mm, this is okay. Observed data will be your TN table. Then you want to find out national-wise some ratio. So now we are trying. We will apply that. We are computing some ratio, national ratios. So from this national ratio, we are getting national table. So this is my national table. This is my national table. This is my TN table. So my observed data will be my TN table. That means state-wise table. Then my national ratio will be national table divided by, you want to find out that ratio, right? Divided by, you give that national, okay, length of that national, okay. So from this what you will get is, you will get that language ratios, okay. You just execute this cells observed equal to TN table and national, okay. You just execute these two cells, you will get that national ratios, okay. So you got some, okay, what you are going to get here, you are getting, you will get language ratios from this, okay. Then what we are doing is, we are trying to compute. Here you have observed value, we are trying to get expected. If you want to get expected, so you need to have expected. How you will get expected value means, I am just taking some expected value. You already found some ratio, right? You take nationwide ratio with product of length of your TN, okay. So this is from this, from the above statement, you will get observed count. That is what you have observed from this Python code. You will get expected count. So you have national ratio, or the ratios, we have used the term as national ratios, then length of your TN, okay. So you try to execute this statement. Now you know your you have your observed data and you have your expected data. Now I am applying that chi-square stat, okay. So already in Python, um, you write, okay, I'm just computing this chi-squared stat, SQASQQARED, chi-square stat. Okay. So now I am converting that math formula, chi-square mathematics formula, into Python code, okay. I'm writing, okay. So you just try to take this one, okay. So how this, that will be observed minus expected. So for expected, observed minus expected, okay, you are going to maintain whole square, right? So in Python, if you want to maintain whole square, you need to give like this, okay. You need to use two multiplication operators, okay. This is, okay, this is your formula for chi-square test. Chi-square, I am giving the name as chi-squared stat. This is my formula, observed minus expected whole square, and you want to divide it by expected, okay. So you need to use, okay, this is one term, I am trying to get that chi-squared value. Okay, then you use sum of that entire thing. Okay, let me execute this cell. So if you don't have any error, this is just okay. We are trying to create data for this observed and expected table. From that, we applied that formula. Okay, can you see? Okay, uh, chi-squared chat observed minus expected whole square by expected. Then you can use some function. Okay, so if you want to print that value, okay, then you use print statement, print of, you use this stat. Okay, just print your chi-squared test value. So what we got is from this we got a value. Okay, this chi-square test we got some value 18.19. Okay, so what does it mean is, so we got some value. This is a chi-squared test value. So I think you already gone through t-test also. In the t-test, what we did is we are trying to compute p-value. Based on that p-value, okay, initially you are going to assume some hypothesis, okay, like null hypothesis, then alternative hypothesis. So if the p-value is less than that confidence level or level of significance, okay, you are trying to accept the hypothesis or you are trying to reject your hypothesis. I hope you already know those basics. Here also we are getting some chi-square value. Okay, so let us assume that like t-test, you are going to assume some alpha value. Here also you can assume some value that will be okay. Um, that value will be confidence. Okay, you just assume 95% confidence level. Okay, some value will be there. We are going to take this value as q will be the one of the value that will be meant for 95% confidence level. Okay, so that means your q value you are going to treat it as 95%. Now what we will do is we are trying to analyze this, whatever the chi-square value we are getting from it, we are trying to analyze a critical value from our hypothesis. Okay, we are trying to compute one critical value, whether we can accept any hypothesis or not. For finding critical values, so you need to use the library as stats, then chi-square will be there. Okay, then just compute your ppf values. Okay, so that will be q. So I am giving this confidence level as 95%, that means 0.95. Then I am going to take my data frame. Okay, so what is the size of my data frame means, so how many number of categorical variables I have? One, okay, English is one, Hindi two, others three, Tamil, Telugu. Okay, so 1 2 3 4 5. Okay, so I have 5 categorical values. So whenever you want to mention, you just mention, okay, your data frame will be always number of categorical variables minus 1. Okay, so here I have, in this example I have 5 categorical variables. 5 minus 1, I am going to take it as 4. Okay, so then you try to print this value, this critical value. Let me execute this cell. So after that you try to print critical value. So and you can see that is whatever the variable name you have mentioned, that is crit. Okay, so this is the critical value we are going to get it. Okay, the critical value will be 9.48. Now what we will do is, okay, we are trying to compute p value. So for that Okay, this is my critical value. Now I am computing the p value like t test. Okay, so for that we have a formula. Okay, p value equal to 1 minus that chi square. Okay, we are going to take that cumulative distribution function. Okay, so you need to use 1 minus stats, then chi square, then you can use that cumulative distribution. Okay, you can take your chi squared value from here, chi squared value from here, then you mention your data frame value will be 4 like previously we mentioned. Okay, then you print your, let me execute this one. Okay, no errors. So then you print your p value. Okay, so this is my p value, print p value. So this is my p value 0.0011. Okay, so if you are assuming uh, okay, your hypothesis. Okay, from this. Okay, if you are assuming some hypothesis, okay, some null hypothesis, if it is the p value is less than this critical value, you may accept or you may reject. Okay, like this you can assume your hypothesis based on these two values, critical values and p value. You can reject. For example, if it is less than your p value, okay, like 0.001, you want to accept your hypothesis. If the critical value is greater than this p value, you want to reject it. Okay, so in this example whatever we are taking, so in this example we are trying to get more value. This is more value 9.48, so you can reject your null hypothesis. Okay, so like this you can do chi-square test on categorical data. Is there any questions? So let me explain one more time. Okay, um, so we are, so what we are doing is in this session we are trying to find out chi-square. Okay, some people joined a little bit late. Okay, let me explain one more time. Okay, what we are doing is chi-squared goodness of fit test. So in this session we are uh, demonstrating this chi-square goodness of fit test by using Python. Okay, so, for example, so if you want to use, okay, if you want to use this chi-square goodness of fit test. Okay, so previously you have seen t-test. T-test is meant for numerical data. For example, in your data set, if you are having categorical data, in such cases, how you are going to do that uh, um, uh, analysis? Okay, so if you are having that categorical data, then you can go for chi-square test. Okay, so I am explaining the chi-square test using Python. You can import this package numpy, pandas, and scipy. So what I'm trying to do is I'm trying to create some data, some categorical data. Okay, like this is fake data based on some demographic. Okay, like I have taken some data like Indian nation and state. This is my Indian nation data first. Okay, I think this one. Okay, Indian nation data. I am creating one data frame. In Indian nation there will be many people, they will speak different languages: English, Hindi, Tamil, Telugu and other languages. I am creating this data. Okay, English will be spoken by 1 lakh people and 60,000 people and 50,000 people, and Telugu. Okay, like this other 35,000 people, they will speak other language. Like this I have created one data. This is national data frame. Another data I am going for state-wise data. Like similarly, whatever I have created here, the same state-wise data frame, English, Hindi, Tamil, okay, like this I have taken, okay. Now what I want to do is I am trying to convert this categorical data into table form, okay. In the table, what you are going to have is the first column you are going to have your categorical variables, that is your languages, okay. So in the second column, you are going to have the count, okay. So the count will be there, okay. In real time your data set will be having like language. Inside that language you are going to have your data in terms of English, Hindi, Tamil, Telugu, others, okay. Like this you are going to have your data, not numerical data. This will be the categorical data. So if you are having such kind of categorical data, you want to convert this one into like table. From the table you can take, okay, the first column will be your language and next one will be you are going to take some count, okay. So you can do this for both national wise data and state wise data. So after that, okay, you are trying to apply size square test, okay. So for that, if you want to apply size square test, I think you already know the formula of size square test. What is that size square test? So you are going to have observed data, that is your actual data, minus expected data whole square by expected. That is your sum of all these things. Okay, that is the formula for chi-square statics. Okay, so what I am doing is I am trying to take the observed data will be state-wise data, that is T and table data. This is observed data. Then I am trying to get expected data. If you want to get expected data, I am applying some ratio. Okay, that is national table length of national. Okay, this is for to get the language ratio. From this I am giving that expected count. Okay, I am getting, you just use this ratio into of that length of the TN people. This is some kind of expected ratio we will get from this data. Then this is your actual size squared stat formula. Okay, sum of, this is sum function, sum of observed minus expected whole square by expected. You get the stat value. So in this example, we got that size squared stat value will be, you just print this value, you will get 18.19. So based on this value, okay, so what we are trying to do is we are trying to find out some critical value and p value. So if you want to find out critical value, you just use, okay, inside that stat, okay, you are going to get that probability functions, okay. You can take that 95% of confidence level and your data frame, you just pass these arguments to for the chi square function, you will get your critical value. At the same time you will get your p value, okay. So you just assume that means you are going to frame your hypothesis, right? So whenever you are framing your null hypothesis, so actually your chi square value will be 18.19. So if you are assuming your hypothesis, for example, if it is greater than this critical value, my chi squared value is greater than this critical value, you want to reject your hypothesis. So in this example, it is greater than, you just reject it. Or if it is less than, so chi square value is less than your critical value, you want to accept it, okay. Or else if you want to consider p value, just based on your assumptions of your hypothesis, you can accept or you may reject your hypothesis, okay. So that is about chi squared goodness test. So this is one way we can do, okay. I will show the another way also, okay. So instead of getting only one categorical data, sometimes what will happen is you are going to get, okay, different categorical data, the like that is different table data. So whenever you are having such kind of data, how you are going to apply this chi square test on that particular data, you want to see the independence of that data. So the next one is chi square test of independence, okay. We'll see the another variety which is present in chi square test, that is chi squared test of independence. Okay. So for this example also, where you are going to use this chi-square test of independence test means, for example, instead of previous example, you have seen only one categorical variable, that is language. Now you assume that there will be more than one, like there will be two categorical variables are there. Okay. In such cases, you want to apply your chi-square test like this. Okay. So if you are having two categorical data, you want to know that that categorical data, is there any dependency will be there among those variables, or you want to know any independence is there. Okay, you want to determine those things. Okay, so the examples for this kind of data. Okay, so for example, in education or politics. Okay, you are going to give some preferences based on various factors um, like we are going to give our demographic data like our gender and our race and our religion. Okay, so in education also we will give some data, right? Whenever you are filling any kind of applications, they will ask some data, some demographic data from us, like gender, race and religion. Okay, so you will get this data uh, from this. Okay, you will get such kind of data sets like gender, male or female, race means whether you are a black man, okay, some kind of white man, or you are Asian, or you are foreigner, like this. Okay, religion like Hindu, Muslim, Christian, like this. You are going to get those categorical data. Based on that, you want to apply. If you are having more than one categorical data, again how you will do it. Okay, this is chi-square test on independence. Like previous example, I have created one fake demographic data. Here also I will generate some fake data. So this data majorly meant for, okay, like some fake water polling data, like some voting. Okay, some voting is there. For that, I am creating some data. So initially, you just take, okay, initially you just read um, randomly. I am taking some data. Initially, you just take random dot seed 10 values, seed. So what I am trying to do is I am trying to take some random data. Initially, I have used random dot seed. Then what we will do is I am trying to give create, okay, some data now, some simple data randomly at fixed probabilities. Okay. Now you are going to assume some race is one of the variable, that is racism. Some, okay. So inside this race, I am creating a data frame. I'm just taking some data. Instead of data frame, I am just giving a random data. Okay. Previously we have seen data frame, that is random choice. We have some choice like A will be like you want to see that race will be either he is Asian, Asian is one of the racism or race. Then give another thing as like black, white. I'm creating this data randomly, black and white. Mm, just copy, paste. I have created Asian, black, white. At the same time, you give Hispanic is another kind of race, then others. Okay, like this I have 5 different kind of race for voter. Okay, so along with this race I am passing this probability also. I am feeding some probability values. Okay, so for Asian you take 0.005, then 0.15, 0.25, 0.05, then 0.5. So the size of the sample will be, just assume, some 1000. So what I am trying to do is I am trying to create probabilities do not sum to 1. Okay, 0.05, 0.15, 0.25, 0.005, 0.5. Yeah. So what I'm trying to do is I created one categorical variable, that is race. Inside that race, there will be different people: Asian people, black people, white people, and Hispanic, and other people are there. You just the sample size is 1000. You just take these people randomly with this corresponding probability. Okay. Similarly, this is fixed probabilities. Okay. Similarly, I'm going to create another variable, that is voter party. This is, now I am telling that voter party also. This is race. These kind of people belongs to this particular political party, and this another kind of people belongs to another political party. So I am trying to create another variable, that is voter party, like this. Okay. Uh, so this voter party also, I am just using the same concept. I am taking it randomly. So instead of this, what we are going to have, I am going to include political parties. Okay. So the first argument will be, like, this may be democratic, or if you want to know, okay, we will give some other name. Okay, like BJP and INC, Indian National Congress. This is political parties. Okay, or you can take any independent other party. Okay, or you just name it as Republic. So like this, 3 parties will be there. Okay, and you take the respective probability. Okay, like BJP 0.4% and National Congress 0.2%. The other, you just take other people will be 0.4%. Okay, so this is your sample size. So this is another categorical variable. Okay, now what we are doing is, from this data, now I am creating my data frame. Okay, here I will get some data randomly. From this data I am creating the voters. So voters, now I am creating data frame. Voters equal to pd dot data frame. Okay, so inside that you are going to have these people, right? Race, and what is the data frame? You are going to take that race and voters. Okay, so one variable will be, one categorical variable will be race. This race will contain the data of voter underscore race. Okay, so this voter underscore race will be here. You will get data from this statement. Okay, so similarly you will get the other data, that is party means voter belongs to which party. So this is party, voter party. You just use same notation, whatever you have used, okay, small v, voter party. So this is one thing, voter race. Just close this parenthesis, not here, you can close it here.
So P is
Voter,
still capital. Voter party.
voter party, yeah,
P
yeah,
is P is capital.
P small, yeah,
Yep.
P small, right?
Yeah, yeah.
Yeah, yeah. So now you have created a data frame with the help of these two categorical variables. Okay. Now what you want to do is you need to create a table, right? Like previously we have created one table. Okay. So for this, you want to have some tabular data. So for that, voter tab, I'm just creating this tabular data. Okay. PD dot cross tab. So the cross tab will contain the data of voters dot race, then voters dot party. Just give your margin, okay, that is tabular data. You by default give your margins will be true. Okay, this is my voter tabular data. So you need to specify, okay, the columns, the index values, okay, based on that, whatever the data we are getting from this here, this random charges, whatever you will mention, you will get the tabular data, okay. So this is voter tab. Now what I am doing is I am trying to give the column names, okay, and the indexes, okay. The column names will be political parties like BJP, INC, and Republic Party, and the index, that is rows. Rows will be the kind of people like race, okay. Um, if you are confusing with this, okay, you can take instead of this black and white, okay, you may use other notation also like Tamil people, Telugu people, Hindi people like this, okay. Maybe based on language, like previous example we have taken language, right? Similarly, the Hindi people and English people, okay. I'm just renaming this race with language, okay. Now what we are doing is I am trying to create columns. So for these columns, voter underscore tab, okay, you need to specify that column. So the columns will be voter tab columns. You can specify at parties. So you have three parties. Just take those three things. Take BJP, INC. Okay, this is my columns. So along with these columns, I am trying to add one more thing, that is row total. Okay, we will get some count row. Just use either small or capital row totals. So this is my columns. Let me check, is there any error? No error. So the next one is you want to give your index. Okay, like index will be based on this water tab index based on these values. Whatever you have taken racism, this is my index. This is my index. Tamil, Telugu, Hindi, English, and other. So along with this, I'm adding some more, that is column totals. I will give the name as call underscore totals. Call underscore totals. So what I'm trying to do is for each and everything, we are creating a 2D table, tabular data. So this tabular data will have in columns have political parties, okay, BJP, INC, and Republic. and we are having along with that values we are going to maintain some count. Okay, this row totals or count both are same one. In previous example also we used count, but instead of direct count I am using as this thing as row totals and column totals. Okay, so now what we will see is we are trying to see that data. So if you want to see the data, you just use that. We will see just 1 minute. Water underscore tab. So if you give, if you want to see the data, how it look like, okay. So this is your data, whatever you have created now to apply chi-square test of independence. So the data will look like this is your political parties. So previously I have given Asian and all. It's taking the same thing. I will execute this. Yeah, now it changed. Okay, so see, this is based on languages. These many number of people is there. This is belongs to this party, this party, this party, and that total will be here. Okay, like column also this will be here. Maybe the size of the sample will be total will be 1000. Okay, so like this you can get your data. You can create a data like this. Okay, so now you are going to have different categorical data. Now what we will do is you need to apply chi-square test for this tabular data, right? So for that, first you need to found observed data. The same formula for chi-square test, observed minus expected whole square by expected. Okay, sum of that function. But in this case, instead of applying that sum function once, you need to apply it twice. Okay, I will explain this one. Okay. Uh, okay, sorry. So the next what we will see is we are trying to take that observed data. So the same name I'm using, observed equal to water. Your data will be water tab will be your data. Water tab will be your data. From this water tab, okay, I'm taking the rows and columns. Okay, so this is how you can able to take the location. So 0 is 5, that will be represents rows, and 0 is 3, that will be represents your columns. Okay, so I have 5 rows, 0 1 2 3 4 5. Similarly I have 4 columns. Okay, 1 2 3 4. Okay, so I am taking that entire data, whatever the data you are seeing here, this will be my observed data. So this observed data equal to water. From this table only I am taking those values with the help of iLocation. Okay, so this will get the table without totals. So you will get this data. So after that what you will do is you need to find out expected, right? So for expected equal to np dot outer give water. So I have observed data. Now what I am doing is like previous example, I am trying to uh, compute expected values. Okay, water dot tab. So I am mentioning, instead of taking one by one, I am taking that row totals. Row totals, because you are having 2 or more categorical data. If you are having one specific categorical value, you just go that particular count. In this case, why we are going for chi-square independence means whenever you are having more than 2 categorical data, you need to create a table like this, then you can take that row totals. So inside that you need to give the all values 0.5, comma. Similarly, you can take column totals also. I'm just copying this thing. This is my row, and instead of row totals, you give column totals. So your columns will be 3 columns. So 0.3. Then you can divide it by this width. So you have taken your sample size will be 1000, right? So initially you are taking the size of the sample here, okay? 1000, the same value you can give here. Okay. So then you try to execute this. First you execute this one, observe. Then you try to execute expected. I think there is some error. Water tab, column totals, row totals. Double exception or the direct cause of the following. Expected np dot outer water underscore tab. You need to specify water tab, so it is unable to fetch the data. Yeah, water tab, that locations. Okay, so now you get the observed data and expected data. So from this, okay, you create uh, the data frame for this. Okay, so that is how to create data frame for this. Expected equal to pd dot data frame. You give whatever the data you are getting from these tables. Okay, this is my data frame. Now what you will see is you can write and that expected columns and index values. Okay, so this will be expected columns. So expected columns will be your parties. You give this value, this. Okay, then expected index. So I'm just creating. Okay, I'm just creating a table. Expected index will be, this will be your index based on the language categorical. This is your index. So you just execute the cells. Expected index. Execute the cells. Okay. Then you print your expected value. This is my expected. Okay. So if you see this one, okay, so you can able to see there are some values. Okay. So these are different types of values. Okay. So how you are getting these values means So okay, these are different values, right? So how you are getting these values means, see, for example, in this table, okay, these are different values, okay. Whatever the values you are getting, these values are different, these values are different, okay. So how you are getting these values means, so so here what we are trying to do is, so previously you have, okay, in previous example you have only one dimensional table, okay. So in this example you have two dimensional table, like if you are having two categorical data, this is your 2D table, okay. So if you are having one dimensional table, you will follow the previous test, okay, like chi-square goodness of fitness test, okay. So if you are having 2 dimensional table, so in such cases you need to follow this procedure. So how you are getting this value means, for example, you got a value in this cell, you are getting some value, right? So how you are getting this count value means, you want to multiply this particular value, this L value, with row total. For example, this is okay. You want to multiply this 24 with row total, that is 24 into 61. Okay. For that, okay, again you want to take, okay, a cell column total, okay, then you divide it by, after this you multiply this cell with row total and then multiply with column total. So what is your column total? This is my column total, 24 into 61 into 412. Then you can divide it by that with the total number of rows and columns, that is 1000, okay. So you will get the value. If you do that one, you will get a specific cell value here. What do you want? Can you able to off and on? Can you able to ride my bike? You don't have self starter and brakes also. It won't have. Also, okay. You just come as early as possible. Okay. Hmm. So is that clear? How we are getting a specific values? This one, okay. This is my 0, 1, 2 means 0, 1, 2 are my parties, BJP, INC, and Republic parties. 0, 1, 2 are this categorical language, Tamil, Telugu, English, Hindi. Okay. So we are trying to get a different cell values here. How we are getting these values means, you just apply the formula whatever I mentioned. Okay. So you will get those values, okay. So after you are getting this particular, okay, this is just expected data, you have your observed data here and this is your expected data. So now I am applying the chi-square test, okay. I want to see a chi-square stat, okay. So that will be chi squared chi-squared underscore stat. Now I am applying the formula like previously. Now you have your observed data and expected data. Whatever you did in previously, you just try to, or else I will copy the same formula and I will paste it here. Okay. So this is my formula. I'm just pasting the here. So I'm adding one more sum here. The reason is, okay, so you are having two-dimensional data. You need to get the column sums. Again, you need to get, okay, whenever you are having 2D table, okay, you need to get the column sums and again you need to get the sum of the all the columns, okay. For that I am calling this sum of, okay. So this is your actual chi squared stat formula. Then you print that value, whatever the chi-square value, you print it. So just execute. Oh, generally something. It should not be zero. You will get some values. I don't know. Maybe something is wrong. Chi-square start. Can I give? Just 1 minute.
So I think there is space before chai square. I think so.
Space. Where here? Chi-squared start.
No, above statement.
This line.
Yes.
Okay. This one. No space. Mhm. Okay, like you just try like previous examples, you need to get some chi-square value, then you need to compute that critical value and p-value, like whatever we have explained in previous example. The same concepts only you can use it here. Then based on that, you can accept or you can reject your hypothesis. I don't know where it went wrong. Actually, you need to get some value. Uh, Observed. Just, this is my observed data and this is my expected data. Observed minus expected whole square. Hmm. Okay. Uh, okay. Anyhow, I think
Sir, is there any issue of matrix sum or there array?
that's what I'm checking.
Can you try to print observed minus expected?
Yeah. Actually, we are not getting any values. There might be
Actually,
somewhere.
the there's expected values are 0, 1, 2, and that observed is BJP, INC, Republic. So that's why it's not
That's why.
subtracting properly. So we have to rearrange those observed values
Hmm.
as 0, 1, 2 columns basically.
Yeah, yeah. Yeah, I hope you understand this thing. Maybe because of that reason, we are unable to get this thing. This is how we can able to perform this I-square test. Okay. Based on that, you try to apply the same concept. Okay, like critical value computation and p-value computation. Then, based on your hypothesis, either you can accept or reject your hypothesis. I will check expected the same names. No, or else I think I did one mistake. Maybe instead of underscore, I want to use dot. Okay, expected columns. Yeah, I have used underscore actually. Expected dot columns. Okay, you specify like this. This is your expected values. Now you apply your chi-squared formula. Okay, yeah. Now you got some value, right? This is your chi-squared value. So based on this, okay, you can compute like previously we did. Okay, critical value and p-value. The same thing. I am trying to copy that code from the first example. Just 1 minute. So what is that? In previous example, critical value. I'm taking this code as it is. Up to this, okay, you got this value. Now I'm taking this critical value. Okay, I'm just using here. So in previous example, the same confidence level 95%, we are going to take it here also. We are going to take same thing. Instead of using same name, you give crit1. Here your D frame. Okay, previous example I told that um, the DF, okay, data frame will be a number of categorical variables minus 1. So that is 1D data. Now if you are having, okay, uh, 2D data, okay, then what you want to do is you need to take the same. Okay, so how many number of uh, categorical data you have? 1, 2, 3, 4, 5, and then again this is also categorical data BJP INC. Okay, 5 plus 3. Okay, so you are going to have your data frame will be 8. So the only difference between 1D data and 2D data is if you are having 1D data, you use number of categorical variables minus 1. If you are having 2D data, you just count this thing, whatever the number of variables you have. Okay, you just mention that one here. Okay, so that is the only difference you can follow. Then you print this critical values like previous example. Print critical value, then print that crit1. Okay, so this is your critical value. Okay, you will get like this one value. Similarly, you just try to compute the p value like previous example. Just go through that statement. You compute p value 1 minus. How you are going to get this p value is 1 minus the same formula I'm going to use here. I'm taking this chi-square stat, just stat 1 I'm taking, and this d frame as 8. Try to print those p values here. This is your p value. print your p-value. So this is your p-value. So like this, you have your p-value and the critical value and your chi-squared value. You just design your hypothesis based on these values. Either you can accept your hypothesis or may reject it. Okay. So for example, if you want to just you have seen the two types of chi-square test: goodness of fit test, at the same time test of independence. Okay. So now what do in this library? Okay, this SciPy library. If you want to see anything like contingency, okay, there is, whenever you are having this kind of independence tests, okay, if you want to see those counts, whenever you are having this independence categorical value, if you want to see those counts, so there is one more function is available, that is stats dot chi square underscore contingency. Just give your observed data. Stats dot chi score underscore contingency CONTINGC. You just use this one. What it will do is it will print those all those stats. Okay, the contingency results of each and every value. Okay, p value, DOF expected frequency. If you want to use, you can utilize this one. Okay. So to sum up this particular chi-square concept, okay, so where you are going to use this chi-square means, for example, chi-square tests will provide a way to investigate difference in the distributions of categorical values, okay, with the same categories on the dependencies between the categorical variables, okay. So why you want to use this chi-square test means, though these chi-square tests will provide a way to investigate difference in the distribution of categorical variables with the same categories, and there is there any dependency between those categorical values. Okay, so like that, if you want to test these things, you need to use chi-square test. Okay, so for t-test you are going to do is for numerical data. For categorical data, if you are having, you need to go for chi-square test. Okay, so this is about chi-square test. Okay, the next what we will see is cluster analysis. So the next thing is we will see cluster analysis, at least one or two clustering techniques. So I hope you already know some basics of clustering. So whenever in your data set, if you are getting a data, okay, there are different kinds of techniques will be there. Supervised, especially in terms of machine learning, okay, supervised learning and unsupervised learning, semi-supervised learning, okay. So at the same time, we have another learning also there, reinforcement learning. Okay. Anyhow, our interest is whenever you are getting a data sets, you may do either supervised learning or unsupervised learning. This cluster analysis will comes under unsupervised learning. So sometimes what you want to do is you want to group the data, or you want to cluster group or cluster the data based on some specific condition, or based on your requirements or your rules. Okay, so if you want to do such kind of things, okay, you want to visualize the data you want to understand that particular data, cluster data properly, you want to visualize it properly. Okay, so then you can go for this unsupervised learning. So initially you don't have any kind of class labels. In supervised learning you may have some class labels. You are going to train it. Based on your training, if any new data will comes under, it will label it, okay, based on your training. But when it comes under unsupervised learning, you don't have any labels, okay, any proper labels. So it will group the data based on your specific condition. Okay. So I hope you already gone through cluster analysis in NPTEL lecture videos. This is continuation of, okay, I'm just giving demo of that cluster analysis using Python. Okay, I will take one example. So one data set I will take, that is iris. Iris is the famous data set. Based on that, we will see how this clustering analysis cluster technique will work. Okay, so generally we have different types of clustering techniques will be there, like k means means, okay, k is the centroid. Okay, k will be the centroid value. You are going to compute that k value. Yeah, k means the mean itself. You are going to take mean value. Okay, k means which db scan, hierarchical agglomerative clustering. Okay, mean shift, optics. Okay, spectral clustering. Those are different types of clustering techniques. First, we will see a simple clustering technique, that is k means clustering. How it will work means, so initially what it will do is, you will have some data points. Okay, so each and every data point, so first you just group some clusters. Okay, randomly you just group some clusters. Then after that, what it will do is, it will compute the Euclidean distance. Okay, so the distance between 2 points, it will compute it. Okay, then initially you have some centroid. Okay, you are going to have a specific cluster have one centroid, another cluster have another centroid, another cluster have another centroid. Okay, so you have those centroids will be there. So each and every time, whenever a new data point is coming to that particular cluster or group, okay, then what will happen is, your centroid value will change. Okay, so this is how the k-means clustering will work. Okay, so let me explain this k-means analysis using Python. So for that, what you want to do is, you just download iris data set. You just take 2 to 3 minutes to download that iris.csv file from Google. Okay, this is very famous data set. You can get it from GitHub or Kaggle. Okay, you just download that one. You try to read that CSV file. You take 2 to 3 minutes time to read that iris.csv file. Once you have that file, I will explain. Okay, what is this k means, how you are going to analyze your data. Okay, uh, okay, I'm also doing parallelly. Just take some time to read that iris.csv file to your drive or to your Colab notebook. Okay, I'm just sharing that link also, where you can get this iris, this very famous data set. I'm sharing that link in your Gchat also. I'm just sharing one GitHub link. You download that iris data set from that Google chart link. Then you try to upload that iris data set into your drive. So that is zip file, whatever the link I have shared, that iris data set is zip file. You unzip it and you try to upload into your drive. So I am trying to upload into my drive. So I'm keeping it as in my folder, that is week 10 folder. So I have uploaded that iris.csv into my folder, week 10 folder. So now it's in my drive. I hope you also upload that file into your drive. So the next will be you want to read the data. Okay. So if you want to read the data, so what you want to do? First, you need to you need to mount your drive. Okay. So you mount your drive.
Hi, your code screen is not visible. Like we are stuck at cluster analysis.
Yeah, yeah. Just a second. You just download that file and you upload into your drive.
Okay.
Uh, then you try to mount your drive. Uh, can you able to see my screen now?
Yeah, it is visible.
Okay. Okay. So if you want to drive your mount, sorry, you want to drive, sorry, you want to mount your file, okay? You need to use from google.colab. Import your drive, then drive.mount. It will ask some permission. You need to give permission. I think I didn't give. It will ask some permission. You need to allow. These are basic Python uh, how to mount your drive. In my first week or second week sessions also, I have discussed this thing. You just use these statements to mount your drive. After mounting, what you want to do is, actually my file is there in my folder. Okay, in my drive, I have a folder called, okay, like PMRF and PTL, that course name like this I have. I want to read, okay, it maybe varies, okay, whatever the path you are going to have. So, so in my week 10 folder, I have this iris dataset. Let me see whether I can able to. If you want to read CSV files, you can use pd underscore read CSV. Okay, now I don't have any issues. So my file is there, iris.csv. I have, if you want to see what is the data, you may use. So this is iris dataset. You just print that data frame. So this is iris dataset, very famous dataset. So which will have different column names. Okay, like iris is a kind of uh, uh, flowers. Okay, flowers dataset. It will have some sepal length, sepal width, petal length, and petal width. Based on this, they want to classify what kind of flower it is. Okay, it is Setosa or Rajnika. Like this, they can do. Okay, so based on this thing, okay, based on this calculus, they have 4 columns. One is sepal length and sepal width. Another one is petal length and petal width, and that variety of that flower. Okay, that's this very famous data set. I hope all of you read that CSV file and you can able to see your data like this. Okay, I'm expecting you did this one. Okay, so if you want to, instead of seeing all this, this is having 150 rows and 5 columns. 4 columns will be your attributes. Another one, the last column is type of that flower or iris. Okay, 150 rows will be you are having 150 rows of data. This data set is size of 150 rows and 5 columns. Suppose if you don't want to see all the rows, you want to see only few things, you may specify. Okay, data frame dot head. Inside that head, you specify. I just want to see. Sorry, head is spelling mistake. Top 10 rows. You can see like this. Okay, so this is top 10 rows. Okay, so our intention is what we want to do is so this is iris data set. Okay, okay. So these are different kinds of species. Okay, what is our intention is we want to see this data set based on species. Here we have variety. Okay, based on this variety. Okay, for example, this is Setosa is one cluster, Virginica is another cluster. Okay, or else if you want to see more data, this is one. This Setosa is belongs to one cluster. Okay, so if you want to make a clusters like this based on that variety. Okay, so for that, what we are doing is you take data, sorry, data frame, specify based on variety and grouping it as one cluster. Okay, so data frame variety to take PD categorical df, just take df, that is variety. Let me see, df variety PD categorical. So I don't have any error. Okay, so next what we will see is so if you want to see based on this, now what is our interest is we need to see this variety of flowers in different colors and different groups, right? So for that, what we will do is we are trying to compute these values. We have data and category key values. Okay, we are trying to compute that k means we are computing the mean value of that data. Okay, we will compute that mean value. Okay, and we will find out that centroid values. Then we will see all this variety of flowers based on different colors. Okay, we will see. Okay, I will try to type this code. Okay, df variety, there will be variety of flowers. Then cat dot codes instead of categorical, just give. So the next what we are doing is I'm trying to changing the data frame to a matrix. Okay, like NumPy matrix. So for that, so up to now we have data frames. Now I am changing it to NumPy, that is values. So we have four attributes. Df dot values. I think so. These are my four values. That is sepal length, sepal width, petal length, and petal width. So now this is my data. Similarly, we are converting for category also. Category is that is variety of flower. Okay. So category like previous example, category df dot. Okay. So here you can take four, the fourth one. Okay. This is category. Okay. Then I am trying to consider. Okay, sorry. My clusters will be. I'm going to take how many number of clusters means. I'm mentioning that k value as 3. K3 means there are 3 clusters. That is 3 groups. Okay. So now initially I want to train the data. So k is 3 I have given. What is this k3 means? I want to make that entire iris data into 3 groups based on the variety of flowers. Okay. So that's why I mentioned k as 3. Now I want to train my data. For that, now you are going to have your numerical data. You apply your data. Okay, shape. Then this is training data. Okay, the number of features, that is category. Tuple object is not callable.
Shape is an attribute, no, it's not a function. So,
Oh, sorry.
and shape S should be
Yeah.
small.
Shape, is that okay? Okay. Then number of features, that is features in the data. You can take this as c equal to data dot shape. Then initially what it will do is, this k means clustering. Initially it will generate, the first step for this algorithm will be, it will generate random centers. Okay. So for that, for generating random centers, we need to compute mean value. Mean will be numpy dot mean. Then you can take your data. So data. So this is my data, and we are computing the mean value. At the same time, you try to compute your standard deviation value. Then you can pass that. I'm just computing mean, standard deviation, these values. The reason is you want to find out centroid. Okay, centers. Okay. So for that we need mean and standard deviations. So initially the centers will be like this. Okay. For random centers, I am calling this function as random dot random. Then k comma c. Then your standard deviation value. Then you want to add mean. Okay. So this is np dot random k comma k is not defined. So you can define your k. K will be 3. You can define your k in some way. So I have defined the k is 3. So this is the random centers. Okay. Now you want to plot your data. So for plotting, you want to visualize this data. Okay, one particular cluster in one color, another particular cluster in another color. So for that, I am taking the colors. Okay, so you may take any color. So as of now, I am taking blue is one color. Then yeah, we'll see. Blue is one color. Then yellow and green. Okay, so I have mentioned k value is 3. So that is my 3 groups. 3 colors will be there: blue, yellow, and green. So, so then you want to plot some graph. Okay, so what we are trying to do is we are trying to plot scattered plot now. Okay, so for that I am taking one. We have so many data points, like 150 rows will be there. Okay, like for I in, I'm giving that range n. Okay, I'm trying to plot scatter plot. Okay, let's see. Scatter dot plot dot scatter. Okay, this is, then I'm trying to read the data I comma 0, then data. So for time being, you just okay. This is how a so it is showing plot is not defined. Can you please somebody tell me in which package it is
Input
available?
matplotlib
Yeah, you
dot
need to
pyplot.
import. As of now, whatever the examples we have seen, I did not imported that package, so that's why it is showing error. If you want to use, if you want to draw anything, either you can use matplot library or seaborn, right? So I don't have that package, and it is showing error. Okay, I'm trying to. So this is how it looks like. Okay, this is blue color. This is one set of uh, cluster. Okay, this is one cluster. Another cluster. Okay, yellow and green. Okay, this is third. Okay, so this whatever the you have seen, okay, red color, these are your centroid values, okay. So actually, if you observe this graph, this is only initial step, okay. See, actual centroid means it will be here, and all these blue values will be nearby the centroid value, okay. So initially you are having your centroid like this. Then okay, after grouping all those things, your centroid will change here. All these blue color data points will be one cluster. Then yellow color will be here, okay. Then green color will be okay. It may group like this, okay. So this is initial thing. If you work on, if you are adding so many data points, you may get proper clusters and proper colors, okay. So this is kind of if you run this algorithm properly, you will get those cluster values. And one more thing, whenever some maybe some points, some outliers also possible sometimes. No need to worry much about that outliers. So this is how a cluster analysis you can do. Okay, with the help of this knowledge, I hope you can apply this unsupervised kind of cluster analysis in your data set like this data. In this example, we have taken as iris data. We have 4 values. We are trying to compute that mean and centroid values based on this thing, and we have one categorical, that is variety of flower, and we are trying to group it. This particular blue color may be, you just okay, that may be setosa. The another yellow color may be, that may belongs to another type of color, okay. So like this you analyze your data based on this grouping or based on these clustering techniques, okay. So with this um, i'm I'm going to end up this session. If you are having any questions, let me know.
My scatter plot came out a little differently. Like the centers are different for me.
Oh, have you taken the same dataset, same values?
Yes,
Whatever the
because
link.
the for loop gave me the same scatter plots. Only the centers are different. Can you show me
Uh,
that centers formula that you put up a little bit more up? Centers is equal to np dot random. Oh, this one is random. Okay, so that's
no,
why
the
I'm
first
getting it.
step for the algorithm is initially we don't know where will be your centroid for k-means algorithm.
Hmm.
So initially we don't know, right? At the time it will take the random point as centroid value.
But
Then if the data points keep on coming, if you are grouping that one, then what it will do is it will take centroid as one data point. Then another
Mhm.
data point will come. Then it will take the average of the 2 points. Then it will rearrange that centroid.
But in that case, my scatter plot should be same as yours, right? But it's
Yes,
not.
maybe you have taken the same data set. I mean, whatever the link I have shared. Maybe iris data set, some people, it
5.1,
depends on these
4.9,
values.
4.7. See, same values. Same values.
Uh-huh. Okay. Have you given random centroid or any other thing?
And the same
Mm,
centers
this,
formula that you are putting at 159th cell, that one I have put. And rest
okay,
of
okay.
the things are same like.
How many clusters? 3 clusters you have given?
Yes, three clusters.
Mhm.
Yes.
Maybe. Okay. No need to much worry about, I mean, centroids as
Mhm.
of now. This is just
Mhm.
a sample example how a cluster analysis we can apply on different data sets. This, just you take this idea, and if possible, what you will do is you take some 10 rows of data, you try to do it manually, then you will get more idea. Instead of plotting these things, how that centroid is forming, how this particular group is forming, what you will do is you try to take some data points,
Mhm.
you try to group it. For example, I have your data points like 1 comma 2 3 comma 4 like this is one kind of set, 5 comma 6. Another kind of set I may have 20 comma 22, 23 comma 24. This is another kind of set. Then
Mhm.
you may take 40 comma like this, okay. Then based on this you try to find out the centroid manually and you try to group it, then you will get more idea.
Okay, one last thing. Can you print your centers variable?
Yeah.
Mm.
See, this is random. It may take some value for me. It may take different value for you. Random means it won't take same thing, right?
Right, right, right.
This is random, okay? Even if you are giving random means it will vary for you and it will vary for me. It won't be same.
Okay, I thought you said na, that it will start with random, but as it takes more values, it will, you know, be
That,
same.
that will be first step. Randomly, it will take random. The first centroid will be randomly it will take.
Okay.
Whenever the algorithm will repeats for different data points,
Mhm. Right.
then initial centroid is different. After that, it will fix some centroid, right?
Okay.
It will vary.
Okay.
Yeah. Any other questions? Okay. With this, I'm going to wind up this session. Okay. Thank you all. Good night.
Thank you. Thank you for the session. Good night.
Thank you. Thank you. Thank you so much for this.